Selamünaleyküm hocam.
Okay, Salam.
Sorry to keep you waiting. I totally forgot it was at 12:30 in the morning.
Okay, Mustafa. Now we are living in the world of technology. You have a phone, you have laptop, right? We have reminder. And because I have scheduled class, I can extend this, but still without informing if you're absent. Anyway, let's continue, Mustafa, if you are ready. Mustafa, we will talk about quadratic equations. Today we will finish the first part, and today we'll talk about complex numbers and how do you solve quadratic equations in complex number system. Okay, now we have been practicing everything on real number system. Okay, and one
Hmm.
quadratic or is a square root property. Properties are from definitions. And usually when we have property, you have to prove it. When you prove this and use it in solving problems, that actually gives you deep learning. So once again, suppose that we have here something like that. X squared minus a squared. Okay, we have to solve this equation, right? In two different ways, I can solve this. The number one is I can factor this. So if you factor this, that is x minus a. And here we have x plus a is equal to 0, right? It's very commonly used formula, Mustafa. It
Hmm.
must be, a piece of cake. And you know well, but still, I would like to remind you about this. That's equal to a minus b, a plus b. And if you solve this, each one should be equal to 0. So x equals a or x equals negative a. And how about the second method? The second one is just, still using this one. Since x equals a minus a, if we move a squared to the right-hand side, I have this equation, x squared is equal to a squared. Okay. So now if you take the square root, what is x? This x can be plus minus square root of a squared. I'm supposing that a is positive here. And what is the square root of a
Hmm.
squared? That's just a, right? So instead of solving this directly, I can
Hmm.
solve using this method. And since we are going to use this frequently, we are going to use a special name. We call this square root property. Okay. So in real number
Hmm.
system, again, if x squared is equal to n, and suppose that here n is non-negative. If it's negative, it has no real solution. Then what is x? I can just write here x equals plus minus square root of n. Okay?
Hmm.
I usually use this method if we have two terms in our equation and one term contains unknown, the second term does not. Like, for example, x squared is equal to 64, right? And the first step, I can write this as x squared equals 64, and it's the square number, which is equal to 8 squared. So dot, dot, dot, what is x? X equals plus minus 8. Okay?
Hmm.
Let's practice together, Mustafa. You just tell me, let's finish this. We have 24 questions. We can solve them maybe in 10 or 15 minutes. Okay. All right. Let's
Hmm.
go. 14. Just tell me, dictate, I'm going to write because if you can't tell me what to do, and I believe that also you'll be able to do this in your notebook.
Okay. First you move the 8 to the other side.
Okay.
That would equal 24.
8, 7.
Oh, right, minus, my bad.
15 minus 8 equals
Um,
7, right? Next.
and then divide each side by 7.
Uh-huh. That's equal to 1. Dot, dot, dot. What is x?
X is 1
Plus minus
or
1.
square root of 1. Yeah, plus minus 1.
Plus minus 1. Okay. 15.
Minus 5 from both sides.
Okay, so 81 x squared equals
Um, 16.
16. Next,
Mm, divide 81 from both sides,
yeah.
but it's gonna be a pretty high
So we can
fraction.
simplify just by the 16 over 81, right? Or we know that that's equal to
Mm-hmm.
4 over 9 squared.
Mm-hmm.
Okay, that's it. Now, what is x?
4/9
Plus minus.
plus minus 4/9.
Because it has two roots, right? One is positive 4 over 9. The second one is negative 4 over 9.
Hocam,
Yes.
just saying my internet is very laggy. So sometimes it like writes it down like very late or like your voice I can't really hear too well.
Why?
I have one bar.
What company are you
My
using?
internet is very bad right now.
Hmm?
Verizon, but like I'm across the house from the internet, so it's a lot laggier and a lot of people are on their computers right now.
Hmm. Maybe you should change it or upgrade it, Mustafa. Also, my internet
Mm-hmm.
connection, it was sometimes when we taught, also my wife teaches online and my kids use Wi-Fi. When we use at the same time, usually in the
Mm-hmm.
evenings, it was lagging. So I called the AT&T. We use
Mm-hmm.
not AT&T. We use Xfinity. So actually, they told me that now we have new internet, faster, and also they told me that I need to change my device. So I changed the device, of course, for free, and I upgraded. I was paying $55. Now I'm paying like 70 something. But it's much faster. It is not lagging. It is
Mm-hmm.
twice at least faster than the before. It's unlimited internet. So maybe you can talk, if because they upgrade,
Mm-hmm.
right? If you have been using this the same thing for a long time, you should upgrade this. The difference will be maybe $10 or $15. It will be much faster, and also signal will be strong.
Mm-hmm.
Because if you're using in the same room, you have one antenna, you should not have this problem. If you're using better one, of course, if you're using lowest one, now I changed this just this month at the end of the March. Now I don't have any problem. Even everybody, like 7 people, are using in the house, so I don't have that problem. Now also my antenna is very far
Mm-hmm.
away from me, but now I can see like full bars. Okay, maybe you can call and tell them. I'm sure that they have better
Mm-hmm.
solutions, so they don't have this problem.
Mm-hmm.
Okay, Mustafa, continue. 16.
Minus 1 from both sides and then divided by 8, which gives you x squared
First is
equals
16, right?
2.
Then what is x squared?
Yeah. And then x squared equals 2.
2. Then what is x?
2
What?
or 2 squared plus
Plus
minus.
minus square root of 2, right?
Mm-hmm.
Okay, next. Let's go step by steps. First, we are just removing that something is added or subtracted, right? We are adding 9 to both sides. So 2x squared will be what?
2x squared will be 5. 64.
64. Next, divide both sides by 2,
Mm-hmm. X squared equals 32.
32. Then what is x?
And then um plus minus square root of 32.
Plus minus square root of 32, right?
Mm-hmm.
But usually, if this number can be written as a product of a square number, right, and something, you should simplify this further because 32,
Mm-hmm.
32, what is the greatest number that divides 32?
8 or
16,
yeah.
right? So square root of
Mm-hmm.
16 is 4. So that is the simplest form. In many questions, they ask you to leave your answer in the simplest form. If you just do like this, they may deduct the points. Because when it actually is written like this, I can have better information about this number. So now I can rewrite this plus minus 4 times square root of 2. 18.
Minus 3 from both sides. So
Okay.
9x squared equals 108. And then divide both sides by 9, which gives you 12.
is 12. Okay. Now what is x? I see here 12, Mustafa. I can write it immediately as 4 times 3, right? You see,
Mm-hmm.
4 is a square number. Then what is x?
Four to the 4 times square root of 3.
No, plus minus 2 times square root of 3.
Oh, two. Yeah, my bad. I
Because
guess
square root
number
of 4 is 2. Square root of 3 is
two.
square root of
Mm-hmm.
3. Okay.
Mm-hmm.
Okay. 19.
Minus 4 from both sides, which gives you negative 3x squared equals negative 81.
Mm-hmm.
And then divide both sides by negative 3, which gives you negative 81. 3.
27.
Um, 7.
Because 3 times 27 is 81, right?
Mhm.
Okay.
Yeah.
Now what is, let's see here, immediately I can write 27 as 9 times 3. 9 is a square
Mm-hmm.
number, so this 3, we don't have any square number when we factor this. Now what is x?
X equals 3 times square root of 3
Plus minus.
plus
Plus
minus
minus
3
3
2.
times square root of 3. If you just write only one answer, it will be not complete because we have to list all the solutions. 20.
Mm-hmm. 20, subtract 10 from both sides. So 5x squared equals 300. Divide 5. That gives you 60.
It is 60. And 60, we can write it as what is the greatest square number that divides
Uh, the greatest square number. Hmm. 3 times 2 wouldn't work. Um, 12 times
12 is not a square number.
12. Uh,
4 times 15.
hmm.
How to do that?
Um,
Because just check the square numbers. You know, the greatest square number is less than 64. It is less than 60. It is 49. It's not divisible 49. 36, no. 25, no. 16, no. 9, no. It's 4. Of course, actually, you can just say this quickly if you have some experience. So it is 4 times 4 times 15. Okay.
mm,
So x is equal to then
mm,
plus minus 2 times
2
square root of
times.
15 because it's asking the exact answer.
Mm-hmm.
Okay, that's a 21.
Minus 1 from both sides, which gives you negative 1 over 2x squared equals negative 40.
First,
Um,
yeah, negative
multiply
1 over 2 x squared equals negative 40.
and then multiply both sides by 2 over 1, to
Negative
get,
2.
which you, yeah, negative 2 over 1.
No, just a
Negative times
negative 2.
negative. Oh, okay. Negative 2, which equals 80.
Because if we have what is our property? That is inverse property, right? If we have
Mm-hmm.
1 over a, you multiply this by a. So a times 1 over a is equal to 1. We can say a over 1, but we know that a over 1 is just a. So every time in math,
Mm-hmm.
you try to express everything in the simplest way. A over 1 or a, which one is simpler? A, right? They make the same thing. They actually mean this.
A. Mm-hmm.
So that will be 80, right?
Mm-hmm.
So what is the greatest square number that divides 80?
4 and 20.
No. In 20, we can write 20 as 4 times
2
4
and
is
40.
5, right? Huh?
Mm-hmm. Um,
16
2 and
times
40. Mm.
16 times 5. 16 is a square number. So
Mm-hmm.
now if you take the square root of both sides, then we'll have here plus minus 4 times square root of 5, right?
Mm-hmm.
Okay. Now, Mustafa, let's do question 22. Then I will ask you to do this 23 and 24 in your notebook, and I want to see your solution. And how about 22? we have something squared on the right-hand side, 9,
Mm-hmm.
number, right? So using that the same
Mm-hmm.
idea, this something squared plus 2 should be equal to what? Plus minus square root of 49, which is 7, right?
Mm-hmm.
Now, if you move this 2 to the right-hand side, then we have two solutions. They are negative 2 plus minus 7. Actually, what does it mean, Mustafa? If you just list, the solutions, that means that the first solution is negative 2 minus 7, negative 2 plus 7, right? But now I can simplify
Mm-hmm.
this. If you simplify this, negative 2 minus 7, negative 9, negative 2 plus 7, it is 5. So these are the solutions. Okay? All right. Mustafa, can
Mm-hmm.
you do this questions 23 and 24 in your notebook? Write nicely, okay? And take a picture and send it to me. Do you have a phone now? Okay. So can you take a picture and send it to me? Also, I want to see your handwriting and the solution. Okay. I'll give it 2 minutes.
Okay. Mm.
Okay. Did you finish?
I'm stuck at the final part. I have x equals 3 plus 2 to the square root of 3 divided by 3.
The first one, 23, you divided both sides by 3 first, right?
Mm-hmm.
Okay. X minus 1 squared equals 6. Something squared equals a
Mm-hmm.
number. Then what is x minus 1? X minus 1 should be equal to plus minus square root of 6, right?
Mm-hmm.
And move 1 to the right-hand side, negative 1 to the right-hand side, we'll get the solution. Solution is 1 plus minus square root of 6. That's it.
Mm.
So it has two answers. That means that the first solution is 1 minus square root of 6. And the second solution is 1 plus square root of 6. Exact answers. Okay, Mustafa, do question 24 and also 23. And can you take a picture and send it to me? I want to see your solution in the paper.
Mm-hmm. Okay, I sent it. Okay, forgot to send the answers.
Let me have a look quickly, Mustafa. Let me see. You have one small mistake. I wonder if you can see it or not. Look at your final solution. Where did you make a mistake? Or can you
Oh,
in the
it's supposed
beginning?
to be -7.
It should be -7, right? Because
Yeah.
x plus 7 should be equal to plus minus is 20. 2 times square root of 5 is positive. If you move to the right-hand side, it will be -7. Okay, good.
Mm-hmm.
Now we have finished this part and this quiz parts. I usually have more time and I would test you here. We'll see. Anyway, Mustafa, now let's talk about solving quadratic equations in complex system.
Mm-hmm.
Okay. Uh, in actually at this level, you cannot see the application of complex numbers. You may wonder why actually we are learning this. But in advanced math and application, it has a lot of complex applications. And also, you're just using complex numbers, they give us very beautiful graphs. Especially they have application in quantum mechanics, is very advanced topic. And also in physics, and there's something that involves waves, something is moving, something like this, what happens here. Anyway, now let's not actually, distract ourselves, but let's get some basic idea. Now, I'm just going to introduce something new. Okay, what is that thing? So you know that we have been working until now in this plane, right? We call this coordinate plane or real number system. So here we have x-axis and y-axis and everything here, they are real numbers. If you just pick any points, both coordinates are real numbers. Real number means that you can show the number on the number line. Okay. And how about if I introduce something new? Okay. So suppose that here we have again two lines that
Mm-hmm.
I will call this x, and let me just call this by, what is it? Sometimes I can write I or yi. Okay, yi. So what is I? I'm just defining something new. Okay, the square root of 1. This guy is a really important thing. Okay, in the future we'll see. I'm just labeling the square root of 1 as a kind of special number. It is I. Okay, so this plane is called complex plane. And every point, for example, this one, how can I show this one? So this one is, it is 2 and 1, right? So this one is, it is 2 and the I. Okay, and how about this one, for example? It is -3, right? It is -3 and 3i. So as if actually our unit here is, it is I, 1i and 2i and 3i. Okay. So let's see here,
Mm-hmm.
if you just talk about this one, is interesting. I is equal to square root of 1, -1. Now, what is I squared? I squared is equal to -1. So it was, if I just draw our x-axis, so this one is y-axis. At the beginning, square root of -1, it was here. And the next step, it is here. And the next step is here. It's just waving. It's just going up and down, something like this. The electricity and a lot of particles, they move in a motion of waves. Anyway, so now what we have to know here is I am defining something new. The square root of 1, I'm giving a special name. Your name is Mr. I. It is -1. And we have only a few special numbers in math, Mustafa. One of them is I. What are the
Mm-hmm.
other numbers? That's pi,
Um,
right? Pi, one of the very important number.
mm-hmm.
Next one is E, for example, right? And next
Mm-hmm.
one is, that's pi approximately 3.14, E approximately 2.71. And we have another number, golden ratio. It is phi approximately 1.6. We have a few, it's not a lot, but these are for me, kind of very important, beautiful numbers. It is weird to understand, but it's very important. In application, you see them a lot. And actually, we believe Allah, I think that Allah created a lot of things, maybe using these numbers, I think. Because if you just pick any circle, divide its length by diameter, you see something. But that is pi, always that pi. But these guys are not rational numbers, not integers, they are special numbers. This pi, e, and phi, they are irrational numbers. This I is a complex number. Okay. Anyway, so equations such as x squared plus 1 equals 0 have no real solution. So mathematicians define the imaginary numbers to represent their solution. Why? Because they need it. That's why they actually felt a need to define this. So the imaginary units, right? What is that? That is I. Is defined as, how they define this? I squared, or I is equal to square root of -1. So this is useful when working with square roots of negative numbers. A pure imaginary number is written in the form here. What is that? It is b times I, where b is the real number and I is the imaginary part. Usually in math, complex numbers, Mustafa, is written by z. What is z? Z is equal to a plus b times I. That is the standard form of complex numbers. A is a real part, and this bi is the imaginary part. Okay? All right. Now simplify the following using this I notation, like negative square root of 9. What do we write? This, I can write it as 9 times -1, right?
Mm-hmm.
And what is square root of 9?
3.
It is 3. What is square root of -1? I,
Mm,
right? It's I. We just notate this
mm-hmm.
as I. And how about square root of 196? I can write it as 196 times -1. And what is square root of 196? It is 14. And what is square root of
Mm-hmm.
-1? It is I. So this 14i.
Mm,
And how about -5? We don't know, but I can write it as -5, right? Times -1.
mm-hmm.
So that's equal to square root of 5 times I. Because every time the square root of -1 appears, that's why, they introduce a new notation. Let's just call this by I. Why I? Because it's the first letter
Mm-hmm.
imaginary part. That's why. And how about this AD? We can write this AD times -1, right?
Mm-hmm.
Not square, just -1. Or maybe I can write separately, square root of AD times square root of 1. And now AD, we have just seen this number. AD is, what is AD? 16 times 5, right? So I can write as
Mm-hmm.
4 times square root of 5 times I. Can you do question 5 and 6, Mustafa?
Mm-hmm.
Do it and tell me your answer. What is that? What is this? Writing numbers in terms of I.
Um, 4 times square root of 2i.
Very good. So the 16 times 2, that is 4 square root of 2 times I. 6,
Um, hmm.
This 192, you know, if you don't know, for example, how to find this, immediately break it down into smaller numbers. Divide by 2, it is 9, 6, right? And divide by 2, it is 48. Divide by 2, now it is, what is it, 24. And now 24, we know that I can divide it by 8, right? So it is 3.
Mm-hmm.
So this one is 8, so this one's 8. So I can write it as 8 times square root of 3 and I,
Mm-hmm.
right?
Mm-hmm.
Okay, next. With the question. Now let's use this to solve the quadratic equations. We need them actually to write, to be able to find the solution of quadratic equations. Usually, when they are asking the question, if they are expecting students to solve them in the complex number system, they have to mention it. Otherwise, we assume that it's real numbers. Okay, read the question.
Solve using the square root method. Write all answers in simplest form.
Yeah.
X
It's saying that
squared plus 81.
imaginary solutions, right? That's why that means that we have
Mm-hmm.
to. Otherwise, if they don't write this, this x squared plus 81, it doesn't have solution in real number system, right?
Mm-hmm.
That's why. Okay, x squared is equal to negative 81, right?
Mm-hmm.
Then what is x?
X equals 9.
Plus minus square root of negative 81,
Oh.
right? Because negative is not
Uh-huh.
positive. And now we have just practiced how to calculate this. Negative 81 is equal to, what is it? Negative 1 times 81, right? And
Uh-huh.
square root of 81 is 9. Square root of 1 is, negative 1 is just I. So the answer would be dot, dot, dot. The solutions of this equation will be plus minus 9I.
Hmm.
8,
Um, minus 9 for both sides. 2x squared equals negative 8. And then divide 2, so you get 4,
negative.
negative 4.
Mm-hmm.
Square root of both sides would be x equals parentheses negative 1 times 4, which
Plus
equals
minus, plus
2i.
minus square root of 4. First say plus minus square root of 4, right?
Okay, plus
Now we can
minus square root of
simplify.
4,
Yeah, that is 2I, right?
and then 2i.
So it has two solutions. That is 2I or negative 2I. All right. 9.
Minus 15 from both sides, so you have 4x squared equals 20 negative 24, and then divide 4 from both sides, so you get x squared equals negative uh 8,
6.
negative 6, my bad. And then do the square root, so x equals square root negative 1
Plus minus. First say plus
um
minus.
plus
Plus
plus
minus.
minus square root negative 1 negative 6, um which equals
Square root of 6 times I, right?
negative. Uh-huh.
Square root of 6 was plus minus. So that means that the first root is negative square root of 6 times I. The
Mm-hmm.
second root is positive square root of 6 times I. Okay, question 10.
Minus 14 from both sides. X squared equals negative 12. Um, X equals square root of negative 12,
You see, I can write as
which
4
equals
times 3 times negative 1, right?
mhm,
Now, if we just take the square root, what is x?
X equals 2 square root
Plus
3
minus.
I
Mustafa, you see here, plus
plus
minus
my
2
plus minus 2 times the square root of 3 times I.
I. That's it. Okay. 11.
Add 5 to both sides. 3x squared equals um 441. Divide 3 by both sides. you get 100 and
47, right?
um uh-huh.
Because 4 divided by 3 is 1, 14 divided by 3 is 4, 21 divided by 3 is 7. And now we know that 147 can be written as 49 times 3, right?
Uh-huh.
I can just write 147 equals 49 times 3 times negative 1. Okay, dot, dot, dot. What is x then?
Square root of 9 would be 7 times square
Or
root
say
of
plus minus.
3
Mustafa
times
say plus minus.
plus plus minus 7 times square root of 3 times I.
I. Okay. Mustafa, now can you do question 12 in your notebook and take a picture and send
Mm-hmm.
it to me?
Okay. Okay. I'm taking a picture right now.
Again, I told you 4 or 5 times you made the same mistake. If you just were like this, you don't get full score. It's not all the solutions. It must be plus minus, Mustafa. That's our main topic now.
Yeah, I just
We
took a
say
picture.
that at the top, we say that if x squared is equal to a squared, x must be plus minus a. Otherwise, it is not complete. So here, x squared is equal to 18 divided by 2 multiplied by 3 is 27. So that's equal to minus 27, which is equal to 9 times 3 times negative 1. Dot, dot, dot. What is x? Since squares, I should write it plus minus 3, square root of 3, and I. Okay? All right. Now,
Mm-hmm.
let's talk about the powers of I. You see, since we define, it's a definition, right? The square root of 1, we define this as I. So what is
Mm-hmm.
I to the power of 1? It is just square root of negative 1, right? It is just square root of
Mm-hmm.
negative 1. We have nothing to do with this. And how about I squared? It is I times I, right?
Mm-hmm.
What is it? It's equal to
I times I, -1 as well.
negative
Square root
1.
of -1.
Negative
Yeah,
1. You see?
-1. My bad.
But now this
Mm-hmm.
I cubed, I can write it as I times I squared, right? And then now we
Uh-huh.
can just calculate the I squared. That's equal to negative 1. So it should be minus I.
Uh-huh.
And I to the power of 4, that is I squared times I squared. And I squared is equal to negative
Mm-hmm.
1. Negative 1 times negative 1 is 1.
Mm.
I'm just using this property. What is a to the power of m plus n? That's equal to a to the power of m times a to the power of n. Because also notation and definition. I'm saying that if a is multiplied by itself m times, In a compact notation, we can write it as a to the power of m. So I to the power of 5, now I can write it as I to the power of 4 times I, right? And I
Mm-hmm.
to the power of 4 is equal to 1, so that's equal to I. You see how y actually is a kind of periodic, because now I to the power of 1, I to the power of 5, they're the same thing. And I to the power of 6, we can write as I to the power of 4 and I squared. I to the power of 4, it is 1. I squared negative 1, it should be negative 1. Now, can you
Mm-hmm.
calculate I to the power of 7, Mustafa?
I to the power of 7.
Yeah, what is it?
I to the power of 6 times I.
Mhm.
So that would be
I to the power of
that
6
would
is
equal,
negative 1, right? Negative I.
mhm.
How about 8?
8 would be I to the power of 4 times I to the power of 4,
Which is
which would
equal
equal
to
1.
1. Okay, good.
Mm-hmm.
Now let's calculate these big exponents. I to the power of 15. Is it 15 or minus 15? It's just 15, right? Yes.
That's 15.
Yeah. What is it, Mustafa? Calculate it. You see, these things you should know. You have to use some numbers, like especially I to the power of
Mhm.
4. It is 1.
Mm,
How can you write this if we just split this power? Can you write it as I to the power of 4 and to the power of 3 times I cubed? Because I'm using this property a to the power of m to the power of n is equal to a to the power of m times n. And you know what is I to the power of 4, right? It is 1. 1 to the power of n
mm-hmm.
is just 1. And what is I cubed is just negative I, right? And how
Mm-hmm.
about 62? That is I to the power of 4 to the power of 15 times 4 times 15 is 60. Now we have I squared. I to the power of 4 is 1. 1 to the power of anything is 1. And I squared is negative 1. Right?
Mm-hmm.
Mustafa, do question 15 and 16. What did you get for 15, Mustafa?
Um, I to the power of 19 times I.
4. 4. I to the power of 4 times to the power of
Uh-huh. Yeah,
19.
I to the power of 4 times the power of 19 time which equals -1.
No, just 1.
Oh.
Because I to the power of 4 is 1, right? We calculated here.
Mm-hmm.
And 1 to the power of anything is 1. And how about I to the power of 4 is 3?
Do it real quickly. Negative I.
Negative I. Because I to the power of 4 to the power of 10 times I
Mm-hmm.
cubed. So that's equal to
Mm-hmm.
negative I, right? negative I. Okay. Now, 3 more minutes, Mustafa, then we'll finish the class. Simplify each expression. Okay. Now, again, just keep in mind that we have a simple definition. What is that? I is equal to square root of 1. Simplify each expression. First, we multiply real part by real part, imaginary part by imaginary part, then simplify. Right? 4 times 7 is
Mm-hmm.
28, and I
Mm-hmm.
times I is negative 1, right? So that's equal
Mm-hmm.
to negative 28. And how about 18? It is negative 4 times 2, negative 8 times negative 9, positive 72. And here we have I cubed, because I
Mm-hmm.
times I cubed. And we have just calculated I cubed. What is it? It is negative I. So the answer is negative 72 times I, the simplest form.
Mm-hmm.
And 19, first we have exponents, right? Again, we just use,
Mm-hmm.
what is that? PEMDAS. What does it stand for?
Parentheses, exponents, multiplication, division, addition, subtraction from left to right.
Yeah. So we have exponents. So we have to use exponent first. 2 cubed. What is 2 cubed?
Um, 2 cubed would be 8.
Here we have 8I to the power of 3. And here we have
Mm-hmm.
5I. If you simplify this, 8
Mm-hmm.
times 5 is 40. I times I to the power of 4. And we know that I to the power of
Mm-hmm.
4 is 1, right? That's
Mm-hmm.
why it is equal to 40. And that's the last question, Mustafa. I squared, right? Let me just simplify first. I squared. Square root of 3 squared is 3 times
3.
negative 8 squared is 64. And here we have I squared. And now equals 3 times 64, 192, right? I squared times I
Mm-hmm.
squared is I to the power of 4, which is equal to just 1. That's why it is 192. Okay, this complex system is, the bigger number system. But usually in high school, you don't use this much. But in the future, if you go to college, if you study like mechanical engineering or any engineering field, you will see this guy a lot in applications. Mustafa, you can
Mm-hmm.
check your schedule. Okay, every day, not every day. If you have a reminder, you should put in the reminder. When is our next class? I think next class is today's Saturday, Wednesday, 8 o'clock, right? If I'm not wrong. Is that correct?
Yeah.
Okay.
Yes.
I will see you on Wednesday. Okay.
Mm-hmm.
All right. Bye bye, Mustafa.
Hey, gosh.
İyi günler.
Bye.